Yeah, good evening, everyone. Switch on your cams. So last class we have finished with Newton's laws of motion. We'll be starting off with friction. Chalo, everyone, cams on. Great. Now let's see. Others do keep your cams on. So if we have to describe this chapter, right, like how we are going to handle this, it's pretty straightforward. Think of like this. Let's say if I tell you there is a one body there, mass m, and there is one force acting on the body, right? And I want you to find acceleration. So you tell me what information do you need regarding this force to find the acceleration? Again, I have one body, I have only one force. I want to find the acceleration of the body. So what information do I need regarding this force in order to find the acceleration? Magnitude and direction. Agreed? So if I know the magnitude of the force and if I know the direction of the force, then I can find acceleration of the block. Simple, straightforward, making sense? That's it. This whole chapter is about finding the magnitude of friction and the direction of friction. If I know these two values, the direction and the magnitude of friction, then step 1, choose your system, draw the FBD, put friction there. Step 2, assign accelerations, find relation between them. Step 3, apply F is equal to ma. Step 4, solve. The entire thing becomes exactly like NLM again. So the only headache is finding the direction and magnitude of friction. And that's what you're going to learn in this chapter. So this chapter is going to teach you only one concept: how to find the direction and magnitude of friction. Once you know that, it becomes completely NLM. And you will see why we have a separate chapter for it. Like I said, friction is a rogue. So let's see what happens with this. So what is friction? So friction, when two surfaces are in contact, there is an opposition to relative motion. Between the surfaces. This property is called friction. Now understand the important word here is friction does not oppose motion. Friction opposes relative motion. Both are completely different. Friction doesn't have a problem with the motion. The problem for the friction is if the two surfaces in contact are having different velocities, that's a problem for me. I'll give you more examples on this. For example, tell me one thing. When you're trying to walk, what is the direction of friction? when you are walking on the road, what is the direction of friction?
Backward.
Okay, then who is making you walk? From Newton's first law, we know if you have to go forward, there should be a force in the forward direction. So who is making you go forward?
Friction.
But just now you said it is backward. Now again, you need to ask yourself.
There are legs exert a force backward.
So what force is that? Muscle force, leg force, fingers force. There's nothing like that. There's nothing called leg force, muscle force, human force. So, see, the thing is, again, remember, when you walk, this is what happens. Yeah. Vihan, is that you?
Yes, sir.
Okay, it's it. Your login, yeah? Okay. I thought some imposter. So if you look at your leg, now see when you walk, how do you walk? This is the ground, your leg is going, this is how you put your leg, isn't it? You put your leg on the ground and you're trying to walk backward. Your feet is trying to come backward, isn't it? So the feet is trying to come backward. That means this point on your foot is trying to go backward. That is the reason, look at your sandals and shoes. The back part of the shoe actually becomes thinner, isn't it? Observe करके देखा कभी? Your sandals, the back part of the sandal is thinner compared to the front part. The back part gets, what do you call it? It becomes much thinner. So this heel here is actually trying to go backward. So when you're walking on the floor, this is what is happening. The point of contact, your leg, that heel is trying to come backward. And the floor is not moving. Therefore, to oppose this, the friction actually acts forward. So the reason you're able to walk on the ground is because of the friction. Meaning, think of like this. If you're looking at my screen, right? See, this is what happens to your leg. Your leg is there. When you hit your leg, how do you hit? You normally hit on the heel. And this is how you try to go, isn't it? Your leg is hitting. And see, imagine if the ground is very smooth, there is some oil there. What will happen? Your leg will slip backward, isn't it? So your leg is actually trying to go backward. So because it is rubbing backward, friction will be forward. You're getting it? Same way, think about your cycle. Can you tell me cycle may on the front wheel, on the back wheel, how is the friction? How is the friction on your cycle ka wheels? This is the main thing. Don't say like because you're going forward, friction piche hoga. That's a blunder. Friction does not oppose motion. Friction has nothing to do with the motion. What friction is looking at is to oppose your relative motion. So think about it. When you have your cycle, the front wheel and the back wheel, how is the friction acting? Did you ever play this? At least I used to do when I was a kid. I used to put the cycle on a stand and I used to rotate the pedal very fast and then used to leave the stand. Kabhi kiya? It just goes off in the front. Ever did that? So if you think about this, so if you have a cycle, this is your pedal, whatever. And then you have your front wheel connected to this. I'll just leave it like this. Now see what you're trying to do. When you're pedaling the cycle, what you're doing exactly? You are trying to rotate the wheel, isn't it? The back wheel is trying to rotate. That means if you look at this point here, this point is trying to go back, isn't it? So when we pedal, we are rotating the back wheel. You're not actually moving the front wheel. We are are rotating the back wheel, meaning the chain is connected to the back wheel. So the front wheel has no power or anything. Getting it? So if you look at the back wheel, you're rotating it with your pedal. So this point is trying to go backward. You're getting it? This point tries to go backward. So the friction will act forward. This is the back wheel ka scene. Now think about the front wheel. Now the front wheel has no engine or anything. This support which is there, that spokes or the front wheel, that is pushing. This F is the front wheel is being pushed forward. Because the back wheel is moving, the front wheel is pushed forward because of that rod ka force. That means this point is trying to go forward. That means the front wheel is trying to skid, the friction will be backward. So whenever you're pedaling a cycle, the friction on the back wheel is front and the friction on the front wheel is back. To give you another kind of an example, think of like this. Imagine your friend is standing there and he doesn't want to go. Okay? And you're pushing him. So can you tell me how will the forces will be on them? You are trying to push your friend and this guy is reluctant to go. You're getting it? You're pushing him. Can you tell me how will the friction be on each of them? When you're trying to push your friend, how is the friction on you? This friction will be forward on this guy, isn't it? Because the legs are slipping backward. You're getting it? So this guy is like back wheel. Whereas the friend whom you're pushing, that guy doesn't want to go. The legs are trying to slip forward. The friction will be backward. This is like your front wheel. Are you getting that analogy? When you push your friend or try to do this thing, if you have something heavy in the house and if you try to push it, let's say heavy box and you're trying to push it, you can clearly see your legs are slipping backward. The friction will act forward on you and the friction will act backward on that box. Isn't it? So this is the same scenario you have in the front wheel and the back wheel. There's nothing there on slide 1, right? Just an example.
Yes, sir, done.
Is this making sense, everyone? So when you're pedaling your cycle, this is what is happening. The friction is different. Did you ever hear this word, four-wheel drive, two-wheel drive? Ever heard this word? Most of the cars that we use in day-to-day life, right? Most of the cars are two-wheel drives. That means the engine is only connected to the back wheels. That is the reason if a car gets stuck in a mud, the back wheel, right? If you just accelerate, only the back wheel keeps rotating. The front wheel has no power only. So all the cars that you see on the road, they don't have power for the front wheels. There is only power transmission for the back wheels. This is called a two-wheel drive. The engine is connected only to two wheels. If you observe military vehicles, all military vehicles are four-wheel drives, meaning the engine is connected to the front wheels and the back wheels. The four-wheel drives are more stable, and even if there's a chance of an engine failure, they can use the front wheels and go ahead. Military vehicles, right? So, but the problem is four-wheel drives are expensive. So for day-to-day use, two-wheel drive is sufficient. So all the cars, your cycle is a one-wheel drive. Now I can create a cycle like this. I can create a cycle like this where this has a chain and this also has a chain. When you're pedaling, you're rotating both the wheels. It becomes complex, but it is possible to create such a thing. So now you tell me, let's say if you want to stop a car from going, what should you do? Let's say some villains are going away in a car and you want to stop them. How do you go and stop the car?
Brakes.
The villains will let you into the car. You'll go inside the car and apply the brakes. They'll keep waiting for you. Aa jao karke. Stop the back wheel. How will you do? You'll put your hand over it. Think about it. So if they're trying to run away, somehow, if you're really strong enough and if you can lift the back wheel, like this, you are holding and you're lifting the back wheel. Now, when they start the engine, what will happen? This wheel will rotate. There's no power on the front wheel. The car will just stay there. No matter how much they accelerate, the car will not go ahead. You getting that? So how can you do that? Maybe you and I can't do that, but John Abraham can. Where are you, NLM? Let me show you how it looks.
No.
मुंबई के एकदम सेंटर में
Look at this thing. You can see the audio is there, kya? You're not getting the audio. Wait one sec. I need to stop my audio here. This thing is playing. This thing, this volume is a messed up, right? Okay. Anyways, just let's see the scene. There, John Abraham has come. Villains are there. We are not interested in all this. There is a fight. He beats him. This guy shows he's powerful. Blah blah blah. Fight ho gaya. There, villains are getting scared or they're running away. There. Now see, they're trying to accelerate. There, this is what he does. This is what I was saying. Dekha, when he lifts the car, there. Dekha, back wheel kaisa rotate ho raha hai? So no matter how much you accelerate, only the back wheels will rotate. The front wheels don't have any engine. The car will just stay at the same place. There. So John Abraham has taught us a little physics there. And then see what happens. If you suddenly leave, what will happen? Dekha, the wheel just keeps rotating there. He leaves the car and then see what happens. It just goes off. There. So I hope the concept is clear. अब इतना बड़ा सीन देखने के बाद तो concept clear होना चाहिए. Clear? That is how cars work. Most of the vehicles are two-wheel drive. So when you start the engine, right, only the back wheels are rotating, front wheels don't have power. If that had been a four-wheel drive, the car would have pulled John Abraham and he would have dragged on the floor. So, luckily, it's not a four-wheel drive. Clear with this? Any doubts on this? Lakshya, you're saying something? Or did John Abraham clear that out?
No, sir. So I was asking if putting oil would be more effective or just lifting the back.
Putting oil is more. Putting oil also works actually. As long as you can make it slip, it works. Lifting is too difficult actually. You need to put a lot of workout. Oil is safer.
Okay.
It would slip. If you have really good oil and it produces zero friction, the wheel just keep rotating there. All clear with this? So there, so we established a fact here that, the friction opposes the relative motion. This is what I was trying to show you. So keep this in mind. Whenever someone tells you, right, you are walking, who is making you walk? It is friction. It is not a human force. It is not a muscle force. It is not leg force. There's nothing like that. The reason why a car goes on a road is because of friction. The reason why the cycle goes on a road is because of friction. Clear with this? Great. The first thing. Now, why do we get this friction? Now, if you look at a fundamental level, there are two reasons. Everyone, do adjust your cams a bit. Make sure your faces are visible on the screen. Now, there are two reasons for friction, in two accepted theories, you can say. The first one is interlocking. Second one is cold welding. So interlocking is straightforward to understand. So this theory says, so whenever you have two surfaces, now even though we say the surface is smooth, in reality at a molecular level, the surfaces are not really smooth, they're locked. It's like hills and this crusts and troughs kind of thing, they get locked with each other. So if you try to move them across each other, there is a kind of resistance. Getting it? So even the smoothest surface you take in reality at a molecular level, they're not really smooth. The surfaces are locked with each other. So whenever you try to move the surfaces, this is what happens. This is the reason we get a friction. So when you look at yourself in the mirror and look at yourself and say like, oh, what a smooth skin you have. In reality, when you look at a molecular level, it looks pretty dirty. There are a lot of germs and small organisms which live on your skin. They do come out in the night. They walk around, go for a walk, and get back into the skin. So yeah. So at a macro level, it does look smooth, but molecular level, it's pretty dirty. But okay, that is how life is. The next thing is cold welding. This is the most accepted one. Both are true up to an extent. Cold welding, what happens when two surfaces are touching each other? Now, in reality, when you say, think about, see, when I say my hands are touching each other, if you look at my hands, in reality, if you see, there are a lot of spaces between them, isn't it? If you see, my hands are actually touching at very few points. Every point on my hand is not touching each other. So because of this, what will happen? You get a lot of pressure at these few points of contact. Try to stand on your toes, you'll understand. It puts a lot of pressure on your toes, right? These are the high pressure joints. So when two surfaces are in contact, right, roughly, again, just an approximation, roughly 1 in 10,000 points are touching each other. Means if there are 10,000 molecules, you can say one molecule is actually touching very close to the other molecule. That number is just a variable number. Could be anything. This leads to high pressure. Which creates bonds between them. These bonds are called cold welding joints. So now if you want to move the surfaces, you have to break these bonds and then you have to move ahead. This is called cold welding, because what do you do in a welding? You heat it up and then the materials will connect with each other. But in this case, without using heat, you are connecting them. So that's why we call it cold welding. So these are the two reasons why we get friction. One is because of interlocking, and second, because of the high pressure. They start forming bonds, temporary bonds, they just get connected. So if you want to move the surfaces, you have to break the bonds, means you have to apply force to break those bonds. Clear with this? Then, going ahead, any doubts on this page? Then, a few points on this. So let's say if you put a block, right? Let's say block of mass m, but this block has a smaller area. if you put a bigger block, same mass. Now, if you look at here we have very few points of contact, 1, 2, maybe 3. Here you have lots of points of contact, 1, 2, 3, 4, 5. So we have a larger area. So what happens here? Because the number of points are less, we have a higher pressure. Because the pressure is high, the bonds are stronger. In the second case, the area is more, but remember, mass is still the same. You will have a lesser pressure because pressure is forced by area. That means on each bond, the bonds become little weaker. So what happens here, even though the number of bonds are less here, they are stronger. Here, the number of bonds are more here, but they're weaker. Overall, they generate the same force. Therefore, frictional force is independent of surface area. As long as the surface ka nature, the type of the surface and the mass is same, frictional force does not depend on how much area you're in contact. You take two blocks of same mass, but one has a big area and one is a small area, they still have same friction. It's independent of area in contact. Is that making sense? If you have a big area, you have more points of contact, agreed, but each point will have less pressure. So they are not that really close. Bond is weaker. If you have less points, you have more pressure, the bonds become stronger. So end of the day, the number of bonds into the strength of the bond, the product is constant. Clear with this? Second thing, if you polish a surface, what happens? When a surface is polished.
Sir,
Yeah.
if the two surfaces, the pressure is equal, but one has a smaller area and one has a larger area, then the one with the larger area will have more friction, right?
Come again.
So the two surfaces, they have same amount of pressure, and one has smaller area and one has larger area.
They
And
have
the
same
one,
amount of pressure, meaning you're saying masses are different.
okay.
Masses are different. Obviously, then they'll have different friction. We are talking about the same scenario, right? Same mass, everything same. Only the area is different. So now when a surface is polished, what happens? Something interesting happens. Initially, friction decreases. Basically, you're making the surface little more flatter. So initially, interlocking will decrease. So friction decreases. But you get too greedy and you start polishing more and more. Friction starts increasing. If polished further, now you're bringing more and more points into contact. Basically, the nature of the surface changes. Cold welding will start increasing. And therefore, friction increases. So till now, we are saying the surface na smooth surface. That is actually a blunder. Smooth surfaces have very high friction. Smooth does not mean frictionless. So if you try to plot this on a graph, friction versus polishing. So initially it decreases and then it rapidly increases. As you keep polishing more and more, the friction bumps up. So tell me one thing, when I say smooth surface, what do you imagine? When I say smooth surface, people imagine like, perfectly flat surface and all. But you know how it actually looks? Ever seen this thing? Box of laddus? Each laddu is a molecule. The flat surface looks like this, a box of laddus. So if you take another box of laddus, what will happen? Each molecule is touching each other, isn't it? So if you have a perfectly flat, smooth surface, right? and if you take two of them and if you attach them, they'll become one single block. There's no need to do any welding. But the problem in real life is if you take a perfectly smooth iron block, if you can somehow create it, because iron is a pure metal, it creates an Fe2O3 ferrous oxide layer on the top of it. So even when you touch them, they won't form a bond. So if you can have perfectly two smooth surfaces and when you touch them, they'll become one single block. So smooth surfaces actually have in very large friction. So there's a concept like this on welding. You take two surfaces, you polish them and touch them, they become one block. I think it's called friction welding. You can check it out online. They have some pretty good videos. So smooth surfaces have high friction. So the right word is frictionless surface. But anyway, while we solve problems, when we say smooth, we will assume frictionless surface. So be careful with that. We assume is smooth meaning the word got used that way. We can't do anything. We say smooth implies is frictionless, but in reality that is not true. Frictionless is hypothetical. Smooth is something else. Is this clear, everyone? There. Now we know why friction comes. That is the first part. Now let's see how does the friction act. So there, this is how the story started. So friction opposes relative motion. Friction has no problem with the motion. The problem with the friction is relative motion. Then we see the two reasons: interlocking and cold welding. It is independent of surface area, and if you polish too much, it becomes, should we say slippery? Yeah, you can say slippery means that only, frictionless. Like smooth is actually a bad word. When you say smooth, it means actually it's pretty high friction, but somewhere down the line, we started using it in every book, so we say that way. All clear? Any doubts on this? Clear, Arya? Daksha? Nikhil? Sharman, clear with this? Arush? Adi? Clear. Great. Next thing. So listen carefully. This is the first thing. Finding the direction of friction. Like I said, if you know the direction of friction, if you know the magnitude of friction, chapter is over. So the first thing, let's see finding the direction of friction. First thing. So whenever you want to find the direction of friction, assume the surfaces are frictionless. So this is a way to find the directions. The second point, see the tendency of the surfaces to move. Now, observe them and see how they would move without friction. Third, then apply friction in such a way to oppose the relative motion. Now, I'll give an analogy. See, listen carefully. Imagine, let's say we have a person A, okay? We have a person C, and you are the person B in the middle. Okay? You have only one purpose in life. Your purpose in life is to make sure A and C are together. Is the concept clear? Your purpose in life is to make sure A and C are together. Okay? Now you tell me, for some reason, the C started running with 5 meters per second. What can you do to keep them together? Let's think about all the things that you can do. The person C started running with 5. What can you do? Stop C. I can do that. Stop C. Fair enough. They're together. Second, forget about C, make A also run with 5. Aren't you still together? My job is to be together, right? Did I ever say stop C? That is not the purpose. My purpose in life is to make sure A and C are together. So I can stop C or forget about C and make A run with 5, or I can decrease the speed of C to 2.5 and make A ka speed also 2.5. Is that making sense? I can do 3 things. I can stop C, or I can make A move, or I can decrease the speed of C and increase the speed of A. Is there any other way that I can do anything here? Is this logic making sense? Now, by Newton's third law, if I apply force on C, I will get a force on A also. That means out of all the options, the third option is the most feasible option. Because if I try to apply force on C by Newton's third law, I will get one more pair of forces. Is that making sense? This is the main job. So here the friction is the point B. So the job of friction is to make sure they're always going together. Fair enough? So think of like this. So when you say there are 2 blocks here, A and B, this is what is happening. The 2 blocks are actually connected by the cold welding joints. They behave like springs. We can treat them like springs. So each spring is like a bond. Now see how to get the directions. So case 1. Listen to this cases clearly. If you got this, you'll get the directions. It's pretty straightforward. So let's say we have block A. I don't care about the masses. We are just interested in the direction. Let's say this surface is rough between them. Let's say A is going with 2 meters per second and B is going with 3 meters per second. Now, can you tell me the direction of friction on A and B? Logically, sochte, okay? Now, there are springs, right? Remember, if there is no friction, what will happen? Who will go front? If there is no friction, who will go faster? P, right? So B thoda aage chala jayega, something like this. That means the springs will become like this, isn't it? Do you guys agree? If B is going faster, won't the springs become like this? If the springs become like this, now you tell me, what will the springs do? So this springs will push A forward and will oppose B backward. Is that making sense? Think of this. This is your job, right? A is going faster, B is going slower. So as a friction, what is your job? You oppose the guy who is going faster and you support the guy who's going slower. Is this making sense? So the springs will get stretched this way, so they'll apply force this way. Case 2. Let's say A is there, B is there. Let's say this is going with 3 meters per second. Let's say B is going with 1 meter per second. Now, how will the friction be? Again, your job is not to stop them. Your job is to make sure they go together. Who is going faster? A is going faster and B is going slower. So whom should you support and whom should you oppose? You should oppose A and you support B. Make sense? So whenever you get confused about the direction, just think about the spring analogy. Suppose if you have A and B, this is going with 2 meters per second. This is also going with 2 meters per second. Now what will you do? Now what is the friction? 0, right? If you both are already going together, why should I do anything? The springs will be loose, isn't it? There'll be no elongation, no compression, nothing. Any doubts on these 3 cases? Easy? All 3 cases are clear?
Sir, in the previous slide, why
Hmm.
would the third option be the most feasible one?
Because whenever, if I try to stop you, I have to apply a force. By third law, I'll get one more force. What will I do with that force? That I have to apply on A only, right?
Yes, sir. Yes, sir.
So there are 2 forces always. So those forces say, matlab, one will slow you down, one will speed you up maybe. I have to use that somewhere. Case 4. There, I'm dividing all
Sir,
this
can
into
you show the
cases.
third case? Okay, sir.
Same velocity, so there's no friction. Suppose A and B both are there. Let's say A is going with 2 meter per second. B is going with 1 meter per second. Now what is the direction of friction? What is the direction of everyone? Focus, focus, everyone. Listen to the class. This is what happens. Might look like little basics only. These things only will help you later on. You want dangerous problems, you will see. I'll make you cry, don't worry. But focus on the basics first.
The B
What is the
forward and
direction of
A
friction?
backward.
Got an answer? Always type in the chat box. Let others also try. You can type in the chat box to the co-host here. You should definitely type your answers there. What is the answer now? Look at here. Now here both are trying to run away. So what will I do? Oppose A, oppose B also, no? You're getting it. My job is straightforward. If both are running away, I'll catch both of them and pull them inside. Make sense? So just think of like springs, isn't it? The springs will become like this. So it'll pull this way, it'll pull this way. Friction has only one role in its life. It is to make sure both to go together. For that, I can support, I can oppose, I will oppose both of them. The next thing. Any doubts on case 4, please ask. Suppose if I have A and B like this. Let's say speed of A is 10 meter per second. Acceleration of A is 3 meter per second square. UB is 5 meter per second. This is also 10 meter per second. Acceleration of B is 1 meter per second square. Now what is the direction of friction? Both have same velocities. But if I give little time, next moment who will go faster? A, right? Yep. So if velocities are same, compare accelerations. So priority one is always velocities. Because if I give a small time, the A has more acceleration, the speed of A becomes greater than speed of B. So in this scenario, so A ka friction will be backward, B ka friction will be forward. So if velocities are same, compare accelerations. So priority one is always velocities. Any doubts on case 4 and case 5? Clear na, Arnav? Arush, clear with this? Arnav? Jainil? Arnav, clear?
Sir.
You don't look well. What happened? Not well?
No, sir. I'm down with cold.
Take care, take care. Case 6. Let's say this is a good one. We have A here, we have B here. Let's say speed of A is 6 meter per second. Acceleration of A is 1 meter per second square. Now, how did we get these velocities and accelerations? Don't worry about that. UB is 2 meter per second. AB is 2 meter per second square. Now, can you tell me the directions of friction? This example will tell you why friction is a rogue. Did you notice something? Initially, A ka speed is more, but B ka acceleration is more. So if you take a situation VA is equal to VB, some point where speeds will become same. So UA plus AAT is equal to UB plus ABT. This will be 6 plus t is equal to 2 plus 2t. You will get t is equal to 4 seconds. Meaning for t less than 4, speed of A is greater than speed of B. So the friction will oppose A because it is going faster and it will support B. So once you cross 4 seconds, speed of A becomes less than speed of B because speed becomes more. Now, because B is going faster, friction suddenly changes direction. In the middle of the problem, friction changes direction. We have never handled a force like this. Till now, normal reaction, tension, spring force. If the tension force is T, it was always T. It never did anything like this. Somewhere in the middle of the problems, things never changed. Friction doesn't care. Friction has only one purpose in life. If you try to go faster than me, I will try to oppose you. Simple. Let that be anything, time change, anything, it doesn't matter. This is what happens. And that is the reason we need to have a separate chapter for this. In the middle of the problem, suddenly B goes faster, friction direction will change. Yeah, at 4 seconds, like I said, right? 4 ka little more, it will be this case. 4 ka little less, it is this case. Exactly T4 we don't define. Because exactly T4 for a moment, it is fine. Next moment, it is going to change. Is case 6 clear, everyone? Any doubts on this case? It's a important one. Taksha, clear, na? We can't say friction is zero. It's like zero time, na? That is a problem. It's like 3.9999999 friction is backward. 4.00001, it is suddenly there. So for solving purposes, it won't matter. It's a negligible time. Case 7. A, B, C, D. A is going with 2 meters per second. C is going with 3 meters per second. This guy is going with 1 meter per second. This guy is going with 2 meters per second. The ground is also rough. All surfaces are rough. Now can you tell me what direction of friction on all of them? Now again understand one thing. The friction between two surfaces is only bothered about those two surfaces. Meaning, if I take friction between A and B, this guy ka job is only one thing, to keep A and B together. It doesn't care what B and C are doing. Are you getting the point? Every friction takes care of only those two surfaces it is touching. It doesn't care about other blocks. Now can you tell me the directions for all this? You can use F1, F2, F3, F4. You got this, you know how to get directions. Take a minute. Whatever you think you do, I'll show you, then you can verify whether you got it right or not. Done? Let's see. Now, just look at A and B, okay? Between A and B, who is going faster? A is going slower, B is going faster. So I should support A, I should oppose B. I don't care about the remaining. Now, between B and C, who is going faster? B and C both are going in the opposite direction. It's like case 4. So I need to oppose both of them. So this guy is F2, this guy is F3. Now, between C and D, who is going faster? D is going faster and C is going slower. So I need to support this guy. This is F2, sorry. And I need to oppose this guy. Between D and the ground, who is going faster? D is going faster, ground is not moving only. So I need to stop this. So this is F ground. Please check the directions of friction. You just need to look at only two blocks. That will be between case 1, case 2, case 3, case 4. It will be one of those cases. When you're looking between A and B, I don't care what is happening between B and C. Please have a look at this example. Ask me if you're confused. All clear with this? There, you know how to find direction of friction. That is the first part. Any doubts on this? No. Now, in sometimes in the question, you will hear the word, the blocks are slipping, blocks are not slipping. If two surfaces have relative velocity, we say they are slipping. Example. So people get confused between slipping and moving. They think no slipping matlab not moving. Let's say this is going with 3 meters per second. This is going with 7 meters per second. So here the blocks are slipping. Suppose this is going with 3 meters per second. This is also going with 3 meters per second. Here they are moving. This is not slipping. So don't get confused between not slipping and not moving. They are moving, but they're not slipping with each other. So when someone says the blocks are not slipping, it simply means they both are going together. It doesn't mean the blocks are at rest. Clear? So that wording is important. Quite a useful statement. It doesn't just stop here. This thing goes to rotational mechanics, no slipping. So whenever you hear the word, the surfaces are not slipping, what it means is that 2 points of contact have same velocity. Surfaces in contact have same velocity. Is this clear, everyone? Ball rolling, let's not get into rolling revo, just we'll see that in rotation. That becomes a completely different game. We'll not get there right now. Is this clear, everyone? Everyone understood slipping and no slipping, right? Because generally what I see, people think like no slipping, so people think it is not moving. Not necessary. They can move, but they don't slip. Next thing there, we got how to find the direction. The second part, finding magnitude. Now, this finding magnitude was completely experimental. Finding magnitude of friction. So this is the experiment that we did. So we have a block here. We attach a bucket here. This is a rough surface. So in this bucket, what you're doing, you're adding sand. So basically you can change mass. So this force will be small mg. So by adding or removing sand, you can change the value of small m. So this is a variable. This is your tension. This is the tension. So friction must be opposite because the block is trying to drag it forward. This is your normal reaction. This is your mg. Now, like I said, it's an experiment. Now you keep on adding sand and we want to see what happens. This is what we observe. As mass m, that is basically the sand, increases. Now this is an experiment, okay? So this is the observation we have. We observe as you put more and more, you have to put the sand slowly. We observe block does not move. Up to a certain value. That means tension is equal to mg. Since it is not moving, friction is also equal to tension equal to mg. That is, so something is happening here. This friction is not constant. So that means as small m is increasing, friction also increases. friction increases, right? And after a certain value, it suddenly moves. At a certain value, block suddenly accelerates. This is what you have observed while doing the experiment. So what kind of conclusions we can make with this? First thing, this force, lot like normal reaction and tension, it is not constant. It can change its magnitude also. So this stupid thing can change its direction, can change its magnitude also. That is the reason it is a rogue. We never dealt a force like this, which can change directions, which can change magnitude. It can just do anything it wants. It's a rogue. That's why you have a special chapter for this. So when we try to plot a graph of this is what we notice. So then people plotted a graph of the friction versus mg. This is the mass of the sander. This is how the graph goes. So the friction ka values initially is 0, increases. Great. Then it suddenly drops and then becomes constant. This is a graph. And we'll see why this happens that way. So this is O, this is A, let's call this is B. This maximum value here, we call this thing F static. Max. This is called static friction. This is called kinetic friction. So what is happening exactly here? So in the OA region, means as the mass is increasing till the critical value, we observe the block does not have any relative motion. It's not moving basically with respect to the ground. So whenever the friction which is acting, when there is no slipping, such a friction is called static friction. And then what happened? The next observation at A, the friction became maximum. How do you know that? At that point, we observe the block is on the verge of slipping. Little force and it will go off. Like I said, all this is an observation. We are not making this out of thin air. Experimentally, this is what we observed. We get maximum friction. It is on the verge of slipping. Then in the region AB, the friction suddenly drops. That was more weird. Now, what happened exactly here? Now, the thing is, when the surfaces move, after applying maximum force, when the surface moves, the bonds are broken, or else the surface will move only. The bonds are broken, and since you're moving, you do not have enough time to form the new bonds again. So they don't form complete bonds, you get some incomplete bonds. Think of like this. Tell me one thing. If I'm standing beside you, you are catching me. Is that easy to catch, or is it easy to catch me while I'm running? In which case, you will apply more force while you're standing, right? So when I'm stationary, you can hold me tight. But the moment I start moving, every time I break the bond and I run ahead, you have to catch a molecule, you have to form a bond in motion. It becomes very difficult. So once the surfaces start slipping, the bonds which will form will not be formed completely. That means the bonds will be weaker. Basically, the cold welding joints. But if you stop the block for a second and leave it, the bonds will completely form. Again, the friction becomes strong. So this was the catch. In order to make it move, it is more difficult. Once it moves, it is easy to keep pushing it. This results in weaker bonds. Therefore, friction drops. That was the reason why the friction suddenly drops. And if you continue pushing after B, once the body starts moving, the friction becomes constant. Now, since this is a friction which is coming, since it is moving, it's called a kinetic friction. Kinetic motion. So this is the friction which is applied when there is a motion. Static, not motion. So when there's no slipping. Now these are all the observations we get from the experiment. Meaning, think of like this. Let's say if I'm just standing here, you and your friend both are catching me. Now you tell me how difficult it is for me to run away. In the second example, your friend is standing here. I am just running and dashing between both of you. And you try to catch me. You tell me in both the cases, in which case do you apply more force? The first case, right? That is what is happening. Once the bonds are broken, you want to form new bonds, but you're not giving enough time because you're in motion. Continuously, the bonds are being broken, formed. So the bonds which form are not formed completely, you get less friction. So the friction drops. That is the reason for this drop in the graph here. Please have a look at this page. Clear? So now, from all these conclusions, finally, we try to get the magnitude. Like I said, again, experimentally, we derived this. So when the block M is there, and when you're applying forces, this was the normal reaction. And what people observed, this maximum frictional force, we call it F static max. The word static meaning when there's no slipping. This is the maximum friction before slipping. This value is proportional to the normal reaction. And when you take the proportionality constant, we get F static is equal to mu into S into N bar. Now, this is wrong. Why? Be careful. You have to compare magnitudes. Can you see F is horizontal, N is vertical? So exam mein na, they'll ask you like this. F bar is equal to mu S N bar. That is how you're comparing vectors. Be careful. Directions are not same. That is wrong. You can compare only magnitudes. F bar is perpendicular to N bar. Friction is tangential, N is this. So what you're comparing is the magnitudes here. So this quantity mu S is called coefficient of static friction. So this is the friction which comes when there is no slipping. That is your first one. Now, I just put down everything. So F static max, this is the maximum force, is equal to mu S into N. But if I just ask you static friction, that is a friction is always less than equal to mu S N. And F kinetic is equal to mu K N. Mu K is coefficient of kinetic. I'll explain you a bit more here. Static friction and maximum static friction are two different words. Be careful. What is the meaning of maximum static friction? How much can I give you, right? The maximum value. What is static friction? How much friction you are giving? Let me give you an analogy. Understand this thing. Listen to this carefully. If you understood this, I think you understood how friction behaves. Let's say Ojas has 1 lakh rupees and he's ready to give it to me. right? Okay, Ojas, you have 1 lakh, you're ready to give it to me, okay? I ask you 10,000. How much will you give me? How much will you give me? 10,000? But tell me one thing, you have 1 lakh, right? Why are you giving me 10,000? I ask you 10,000, right? That's you're giving 10,000. Suppose if I ask you 50,000, you'll give 50,000, but you have 1 lakh, right? Okay. What if I ask you 2 lakhs? Then you will say, sir, I have only 1 lakh, take everything, I can't give you more than this. So the thing is, you can give 1 lakh, but I needed only 10,000. Friction also does the same thing. I can give you Fmax, but that doesn't mean I have to give you Fmax every time. I will give you only how much ever is required. Because my job, friction ka job is what? Is friction ka job to give you full friction? No, friction ka job is to keep you together. Let me give an example that will make things clear. For example, look at this question here. Let's say we have a block here, 5 kg, and let's say this friction mu static is 0.5. And let's say someone is applying F is equal to 5 newtons. Can you tell me what is the friction? Step 1, draw the FBD. Same story. Normal reaction. This will be 50 newtons. Friction will be backward because you're applying force, and this will be capital F. So N is equal to 50. Now what is F static max? So this formula is mu S into N, which is 0.5 into 50. That means 25 newtons. Now just think logically. If this guy applies 25 newtons, what will happen? The block will go back, right? Doesn't it look weird? I'm applying force in the front direction, the block is going backward. If friction gives 25 newtons, the maximum value, the block will start going back. Now you tell me, as a friction, what was your job? What was your job as a friction? To make sure the block and the ground are together, isn't it? Who made it go back? The friction only. Does it even make sense? So what will you do? The thing is, I can give you 25, but in this scenario, I need only 5 newtons to stop the block. So be careful with that. This is your maximum possible value. You are ready to give up to 1 lakh, but I asked you only for 10,000. So the friction is saying, boss, I can give you up to 25. But my purpose is not to give you full force. My job is to make sure there is no slipping. So friction will say, if I give 5 newtons, my job is done. So we need only 5 newtons to stop slipping. Therefore, getting it. But we can provide, but it can provide 25 newtons. You can give 25. So here, friction is 5 newtons. Is this making sense, everyone? So friction will give only how much ever is required to stop slipping. Friction ka job is not to give the maximum value. So this mu s into n is the maximum you can give, but your friction ka value can be anywhere from 0 to maximum. That was what is happening in this graph. If you observe, this graph ka value is anywhere between 0 to maximum. Is this example making sense, everyone? So blindly, whenever you see a free body diagram, don't put mu s into n. You need to check how much you need. Is this making sense? Let me give you one more example. You tell me what is the answer for this. Can you find the friction? Find the friction on the block. Find friction on the block and find maximum friction on the block. Max friction possible. That is the word. That much I can give you if you ask. But if you don't ask, why will I give you? Isn't that just? You have 1 lakh. If I ask you for 5,000, why will I give 1 lakh? You will give only how much ever is required. What is the friction that is acting right now, and what is the maximum friction that I can give? You got an answer? Do type in the chat box. We are having. Okay. So most of it didn't fell into the trap. Clear? Let's see. Step 1, choose a system, draw the free body diagram. Components. This will be 20 root 2 sine 45, which was 20. 20 root 2 cos 45. That was also 20. Your weight was 100. Normal reaction, friction will be backward because the block is trying to go forward. Now, be careful. Don't write F max here. I just wrote F. So what is F max? First of all, what is N? N is 100 minus 20. N is not 100. Be careful. Don't say N is equal to mg. यहाँ पे vertical force भी है system पे. That is a mistake people do. So what is F max? F max is mu s into N, which is 0.5 into 40. I can give you 40. But to stop the block, how much we need? We need only 20 newtons to stop motion. The ground is at rest. If you don't want to, I need only 20 newtons. Therefore, friction is 20. Easy. I can give you 40, but I need only 20. And be careful, N is not 100. N is 100 minus 20. That is a one goof up people do. They forget about that. So blindly don't write N is equal to mg. Is this clear? Great. Then we also define something called contact force. So contact force is the net force between the surfaces. So if you have a block, this is nothing easy. So this is a normal reaction. This is friction. Both are perpendicular. So if they say find contact force, indirectly is asking to find root over n square plus f square. Just keep that in mind. Friction is different. Normal reaction is different. Contact force is different. Contact force is a resultant of n and f. I goofed up this in my JEE exam. They gave in the exam contact force is 40. I thought n is 40. And they gave in the question take G 9.8. I took G 10. I solved the entire problem. I got answer 3.6. It is an integer question. So I rounded off to 4. My answer was right. My friends, on the other hand, they took n is equal to 40. They took G 9.8. They got 3.4. They rounded off to 3. I was plain lucky, but yeah. Clear? With this, the theory part is done. Everything that you need to know about friction, you know. Like I said, there are only two things. One, you need to find the direction. You know, we did 7 cases. You need to find the direction. Now you know. The main idea is this. You always know the maximum value, but you need to check whether you need that or not. I hope you're getting the difference. How much you can give and how much you give are different. Right? Let's see more questions. You'll get the hang of it. Let's see one more question. We have a wall here. Let's say mu is equal to 0.4. Let's say we have a block here. 2 kg. Gravity is this way. Are you getting how is the diagram? It's like there's a wall here and someone kept a block like this. Are you able to visualize how it is? It's a book against the wall. You're pushing the book against the wall. Meaning, think of like this. If this is the wall, this is the block. दिख रहे हैं? I'm applying force like this. Can you see the side view? This is the scenario. The remote is the block. This is the wall. You're pushing it like this. So you're applying a force. F is equal to 100 newtons. Is the diagram clear? Find the contact force. Right, Ahna, Vihan. Ansh. Check your answer, Ansh. That is wrong. You got an answer. Do type in the chat box to the co-host. You should type. It's okay if you get a wrong answer. That is totally fine. Right, Purvaja? Nee, Surya. Contact force. Let's see. Step 1. Choose a system, draw the FBD. There is only one block. Again, like a broken tape recorder, I keep saying the same statements. The reason, when you go to an exam, you see a question, you blank out, you should still be able to solve. What are the forces? Normal reaction, your own weight mg, your friction of capital F. How will the friction be? Again, Socho, if the friction was not there, what will happen to the block? It will come down, right? So friction should be which way? Friction should be up. Do you know the magnitude? I don't know. That is the first thing you should say. You don't know the magnitude. How much is mg? 20 newtons. Perfect. So what is normal reaction? F is 100. So N is 100. Maximum friction is mu s into N. That is a maximum, which is 40 newtons. But how much we need? We need only 20 newtons to stop. So I can give you 40. But if I can give only 20, the block will not slip. I mean, just imagine if I give you 40, how weird it will be. If I give 40, block will climb up. Imagine you push the block and it starts climbing up. There's a ghost in the house. It will be a proper horror movie. Isn't it? Like imagine you're brushing your teeth in front of the mirror and the image is smiling at you. Can you imagine? And you walk away from there and the image is still there and saying, hi, are you leaving? You don't need a big horror movie, right? You can scare yourself. So we need only 20 newtons, right? Therefore, friction is only 20. Done. This is what I'm saying. Directly, mathematical equations won't give the answer. You have to do arguments. I can give 40, but I need only 20. This is the problem with this chapter. So what is a contact force? Contact force is root over n square plus f square. Always be careful. Here, if you see, never write f max directly. If you observe, I always write f only. Never write f max without being sure it is slipping. If you want to write f max there, you have to be 100% sure block slip ho raha hai. Without being sure about slipping. You can write f max only when you slip. If you say, sir, I don't know whether it is slipping or not, then don't write it. Just write f. So what is the answer here? Root over normal reaction is 100 square plus 20 square. Root 10,400. I will leave it there. Clear? Let's see one more. Any doubts on this? 5 kg. Mu is 0.2. Now, sometimes we won't write mu s. If nothing is mentioned, always assume mu s is equal to mu k. So in some of the questions, you'll just see mu is equal to 0.2. Like in this question, I'll just say mu is 0.2. Matlab it is understood mu s and mu k both are same. Which is not right, but okay, problem solving. 45 degrees and this is 20 root 2 newtons. Find the distance moved by block in 2 seconds. Let's get this. Devansh got an answer. Vihan, that is wrong. Nee, Purvaja, that is wrong. Ansh, you're right. Nikhil, you messed up. Arya, what is that? What nonsense is that? Wrong. Arush, wrong. Surya, wrong. Surya, right. How many of you took N is 50? Congratulations. N is not 50. Gods, अभी बताया मैंने F का vertical component है वहीं पे. N is not mg. Don't write it blindly. Step 1. Choose a system. Draw the FBD. This component is 20. This component is 20. This is 50. This is normal reaction. F is backward. Again, I'm not writing F max. So what is N here? N is 30 newtons. Therefore, F max is equal to mu into N. Mu is given 0.2 into 30. This is 6 newtons. Now, in this case, clearly you can see F cos 45, which is 20 root 2, is greater than 20 newtons, is greater than 6. Therefore, which is F max. Therefore, block slides. Therefore, F is max. Now, you proved it that the block is sliding. So now you can write this is F max. Since we know it slips. This is a problem with this chapter. You have to make an argument whether it is slipping or not, prove it, and then use it. If you can't prove, then it will be just F there. Step 1, draw your FBD, write the forces. Step 2, acceleration. Always remember, forces on the body, accelerations outside the body. 20 minus F max is equal to mass into acceleration. This becomes simple loss of motion. This is 20 minus 6 is equal to 5a. Acceleration is 14 by 5. Next thing, initially the block is at rest. You want to find the distance. S is equal to ut plus half at square. Kinematics. Everything comes. Kinematics, NLM, friction. U is 0. Acceleration is 14 by 5. And time is 2 square. That is 28 by 5 meters. Check. 5.6. Clear? Next one. Any doubts on this? Anyone didn't get the FBD equation part? Anything, please ask. Easy one. Like I said, today we'll do just basics. Let's see one more. We have a block of mass m. Coefficient of friction is mu. Someone kick the block with speed u. Find the distance it travels before it stops. So it slides on the floor and eventually stops. The block is given speed u horizontally. Find the distance it travels before it stops. This is an easy one. The actual question is this. The same question. You gave speed u. This is mass m. I'll do one thing. Let's finish off this. I'll give that question on the next page. How do we do this? Yeah, this was straightforward. If you draw the FBD, the block has speed u, the ground is 0. It is definitely slipping. There's no doubt only here. Therefore, F is maximum. Since block slips, again, what do you mean by slipping? If there is a relative velocity, it is slipping. The ground is at rest, block is going, so it is slipping. This is normal reaction. This is mg. Acceleration is backward. So this was easy. So F max is equal to mu into n. This is mu mg. F max is equal to mass into acceleration. So we get A is equal to mu g. This question has become a kinematics question. So this block has speed u. This block has acceleration mu g. This will travel some distance and eventually stop. And you are asking, what is this distance? V square minus u square is 2as. Final speed is 0. Initial speed u square, 2. Right positive, left negative, sign convention. A is minus mu g into s. S is equal to u square by 2 mu g. Easy? Do ask me if you're confused. So once I got the acceleration, it becomes a kinematics problem. Since it is slipping, friction is maximum. How do you know it is slipping? Because there's a relative velocity. I hope you're getting how we are playing around with the words. Any doubts on this? Now this, if they ask you, this will be like a CET level question or even a mains level, maybe both easy. So now if I had to ask you this question in advance, how will I ask you? Turn in the page, any doubts? I have a block here, mass m. You gave initial speed u. This point is x is equal to 0. Your coefficient of friction mu is given by e power minus x. Your friction is not constant. X is the x coordinate. So the question is find speed u so that the block never stops. Just to give a little context what is happening, think about it. At this point, x coordinate is 0. That means what is the friction? 1, right? The more you travel, the lesser the friction, isn't it? If you go to infinity, e power minus infinity is 0. So at infinity, friction is becoming 0. The more you travel, lesser the friction. That means if you kick the block with enough speed, there is a possibility the block will never stop. Is that making sense? Now, in case people forgot, what is E? E is just like a number, 2.713 exponential. We have done this in calculus. And in case you forgot the calculus, e power ax dx ka integral is 1 by a e power ax. This much integration you should know. Try. So here you have a friction which is changing with x coordinate. The more you travel, the lesser the friction you have. So if you can give enough velocity, this block will never stop. This would have been advanced easy level question when you're in 12th. Maybe for now it is tough for you. But when you're in 12th, I will expect this to be like easy question. For now it is tough. Give it a try. You got 2 minutes. Just give it a try, get some water and come. Any answers? 2mex. God, you have to give me in terms of number. Right? X is a variable. How are you giving me answer in terms of a variable? Find u if the block never stops. Let me ask you this. If the block never stops, where will you reach? Infinity. You know what is the inspiration for this problem? Actually, the other way around. This problem was an inspiration for this guy. You saw one problem in kinematics, it never stopped. Anyone remembers? This guy. Remember? Gravity was becoming half every time. This kept on going forever. It never stopped. We got an infinite GP. This was actually inspired by that. This thing looks scary. It's not tough. It's just little max. You just follow your process, right? That's what I'm saying. Don't see the numbers and get scared. What is your process? Step 1, choose a system, draw the FBD. Normal reaction. Your own weight mg. Since the block is going to the right, friction will be backward. And it will be maximum since it is slipping. Every time I'll keep writing this word. You have to be careful. Don't blindly write Fmax without proving it is slipping. The velocity is forward. Acceleration is backward. Your friction is done there. So we have Fmax is equal to mass into acceleration. Fmax is nothing but mu into n is mass into acceleration. Mu is e power minus x, n is mg, is ma. So we get a is equal to g into e power minus x. Friction got over here. What is acceleration? Minus v dv by dx. Why minus sign? Because it is decelerating. If acceleration is opposite to velocity, it becomes minus v dv by dx. If both are in the same direction, then it's plus v dv by dx. Negative since it is decelerating. Now it is kinematics. Then v dv minus is equal to g into e power minus x dx. Integrate on both sides. Calculus. You had NLM, you have friction, you have kinematics, you have calculus. Initially, x is 0. Initially, your speed is u. Eventually, where you want to go. Let the velocity be v and x. I'll just try to solve with that. This would be minus v square by 2. Limits u to v. This is g into, I give you the formula for this. This is minus 1 into e power minus x. Limits will go from 0 to x. So the minus minus goes off. We get v square minus u square by 2 is equal to g into e power minus x minus e power 0. Be careful, e power 0 is not 0. E power 0 is 1. So we have v square is equal to u square minus 2g into e power minus x minus 1. This is plus. This is your velocity. You're getting it? This v square is a velocity as function of x. They can ask this also. Find the speed when the particle traveled x distance. This is the speed. Getting it? Now, since it never stops, velocity must be greater than or equal to 0. That is, x will tend to infinity. Now, if you substitute here, so u square plus 2g into e power minus infinity minus 1 is greater than or equal to 0. We know e power minus infinity is nothing but 1 by e power infinity, which is 0. E power infinity is a big number and 1 by big number is 0. So this is u square plus 2g into 0 minus 1 is greater than or equal to 0. So u square is greater than or equal to 2g. That is, u is greater than or equal to root 20. If you throw this with a speed of root 20 meters per second, this will never stop. Is this clear, everyone? Did you observe one thing? I didn't give a single number here. But the final answer is a number there.
There is a kinematics of question also we got, I think, root 20 only.
नहीं, वो 20 था, root नहीं.
अच्छा.
वो सिर्फ 20 था. Again, listen carefully. Step 1, free body diagram. Everyone knows this. Step 2, F max is equal to ma. Acceleration kinematics. You know how to integrate this. There is nothing that you don't know in this, but the headache is connecting all of them. That takes time and practice. That you will get the hang of it. Is it clear, everyone? Check it out. So there, we started with friction. So next class, when you catch up, the theory part is over. This is what I was saying. Friction ka theory is done. You know everything about friction now. But the thing is, unless you see some models where it, we twist it and we do everything, you won't get the hang of it. So next class, when we catch up, we'll do more good problems. Like I said, the chapter is small because did you observe one thing? It looks more like NLM only, right? Except for finding the direction of friction and magnitude, everything is NLM only. Okay, so with that, we'll wrap up for that day. Right. So next class, when we catch up, we'll continue from here. So I'll see you guys again next week on Tuesday, as usual. So any doubts in today's class, anything you can stay back and ask, also free to leave. So take care, stay safe. I'll see you next week.